Now that we have successfully synthesized our super tough gel, it is time for tensile testing. Generally, this is a 2-week-long lab, but since we are fully online, we can do it all in one day. Just know that the super tough gel normally needs to sit out for a few days before we can begin tensile testing. We will use tensile testing of the super tough gel to measure the stress and strain relationship of the gel. Recall that in Lab 4, we used ball bearings to directly measure the elastic modulus of gels containing various concentrations of gelatin. In Lab 5, we will be using the tensile test machine in order to generate data so that we can then graph the stress versus strain relationship. From the stress-strain data you are given, you can then calculate various parameters including elastic modulus, the toughness, ultimate strength, and failure point. In order to do this, we will first begin by slicing the gel with a scalpel into 3 separate pieces, 3 centimeters by 1 centimeters each. When choosing where to slice the gel, you will want to make sure that you get an area of the gel that does not have many bubbles. After slicing these 3 pieces, you'll want to measure their length, width, and height. Next, we have 2 glass slides that we will attach our gels to. We will use super glue to overlay our gels onto the glass slides by about 1 centimeter on each side. This will help ensure that the gels do not detach from the glass slide during the tensile testing. We want the gels to stay anchored to the glass slides during the entirety of the testing so that our super tough gels will eventually reach their respective failure point and break in half. After we have glued our gels to the glass slides, we'll then wait about 20 minutes to ensure that they are fully attached. This is what your glass slide and gels should look like once they are all attached to the glass slides. Now that about 20 minutes has passed, our gels should be ready for tensile testing. We will do this entire process 3 times. Make sure to write on each of your glass slides your name and the run number. You will have a total of 3 separate runs because we have 3 gels to test in the tensile testing machine. Gently load 1 glass slide into the bottom chamber and tighten the load frame so that the glass slide is firmly in place. But do not over tighten or it might break your glass slide and you will have to reattach the gel to another glass slide and wait another 20 minutes. Now, attach the other glass slide to the top portion of the loading frame and tighten the frame so that the glass slide is held firmly in place. Now we will start up the testing software on a lab computer, making sure that all the settings are configured correctly with the help of your TA, of course, and begin turning the handle in the clockwise direction at a speed of about 100 millimeters per minute. We will do this until the gel breaks. Remember what I said about making sure you wait at least 20 minutes before testing your gel? Well, here's a great example of what might happen if you don't wait the entire 20 minutes. You can see here that the student's gel detached from the glass slide before it was even able to break the actual gel. I wonder who that student was. Well, in fact, it was me. This was my own gel and my own mistake, so just know that you should wait the entire 20 minutes before testing your gel. Here's the actual video of tensile testing this specific gel. At the end of the video, you can see the gel detach from the glass slide and not actually break. Let's look at some more footage of doing the actual experiment. Here's another video of us doing and using the tensile testing machine in order to slowly pull apart another trial of the super tough gel. You'll notice that not all gels break, but some do. In this image, you can see that the super tough gel was about to break. You can even see the necking taking place, especially at the bottom portion of the gel. After you get done tensile testing each of your trials, you will then download all the data into an Excel or CSV file. Since this lab is online this year, you will be receiving data in an Excel file with data from each run. You can then analyze your data, make cold stress strain curves, and calculate the elastic modulus and many other things.